alkene, right? We can synthesize alkene by multiple ways, right? We can synthesize alkene by multiple ways. The first one is preparation of alkene from alkyne. So alkene, when alkyne is partially hydrogenated in the presence of catalyst, what will happen when alkyne is hydrogenated in the presence of palladium, nickel, or rhenium? It converts into alkane, right? Alkene, formation of alkene, in this stage, there is an intermediate alkene form. Intermediate means unstable species or unstable product that convert into, that further hydrogenated into alkane, right? So we cannot carry out this reaction. We cannot prepare alkene from alkyne in normal hydrogenation reaction, right? If you want to hydrogenate it, alkene, suppose when alkyne treated with hydrogen, then it convert into alkene. Once alkene will form, this act as intermediate, and this further hydrogenated lead to the formation of alkane, right? But if you want to synthesize alkene from alkyne, that must use control reduction or control hydrogenation. How we will do this? Alkynes could be used to prepare alkenes if a catalyst were available that is active enough to catalyze the hydrogenation of alkyne, but that catalyst not active enough for the hydrogenation of alkene, right? So for this purpose, we are using landler catalyst, which is palladium on charcoal. We are using palladium on charcoal, or sometimes we are using quinoline, or sometimes we are using palladium on BSO4. But in this stage, we are using palladium on charcoal in quinoline. So when treated alkyne with hydrogen in palladium on charcoal, it convert into alkene, but this alkene cannot convert into alkane by using palladium on charcoal. So this is called control reduction, right? So this control reduction, for example, this is an alkyne, and we use landler catalyst, that is palladium on charcoal. Through dehydrogenation, initially hydration takes place. Control hydration, it convert into alkene, right? So this alkene further cannot convert into alkane in the presence of landler catalyst, that is palladium on charcoal, right? If we will discuss further few more examples of these, here are the examples. Suppose, and generally alkyne, when treated with hydrogen in palladium in charcoal, it converts into cis alkene, right? One is cis and trans. We get cis alkene when we treated alkyne with hydrogenated in palladium in charcoal, we get cis alkene. But if we want to get trans alkene, I'm sorry, there is some misconception here that this it looks like that cis, but actually it is trans. Hydrogen should be here like this one. R. So this is trans one, right? So, but if you want to get trans alkene, alkyne is hydrogenated in sodium in liquid ammonia, we get trans alkene. And if you want to get cis alkene, we just use palladium on charcoal. And if you want to get trans alkene, we just hydrogenate it in sodium in liquid ammonia, lead to the formation of trans alkene, right? For example, how we synthesize ethene from ethine. When ethine is reacted with hydrogen in palladium in charcoal, that is landler catalyst. In the presence of landler catalyst, we get ethene. Similarly, propene can be obtained from propine when hydrogen is treated with propine in palladium in charcoal, that is landler catalyst. Through controlled hydrogenation, we get propene, right? Similarly, you can get butene and so on by using these methods. But the main difference, the only difference is if you get trans alkene, you use this method, that sodium in liquid ammonia, then hydrogenation lead to the formation of trans alkene. But palladium and charcoal hydrogenated with alkyne lead to the formation of cis alkene, right? So this is the first method, preparation of alkene from alkyne. The second method is we can synthesize alkene from alcohol, right? Suppose this is ethanol. When alcohol is treated, in the presence of concentrated sulfuric acid, then through dehydration, alkene form. Through dehydration, alkene form. Basically, alkene preparation from acidic dehydration. Dehydration means removal of water. We are removal of water in this stage. So ethanol, this is ethanol, right? This concentrated sulfuric acid just protonated this OH, right? Protonated this OH, then this conjugate base HSO4 नेगेटिव होगा, जिसके ऊपर जो कंजुगेट बेस है, दिस कंजुगेट बेस एक्सट्रैक्ट प्रोटॉन फ्रॉम बीटा हाइड्रोजन और इस कार्बन के ऊपर नेगेटिव चार्ज आ जाएगी, ये इस वाटर को एलिमिनेट कर देगा एंड दिस HSO4 extract this proton and it is recovered now. So basically when alcohol is treated in the presence with concentrated sulfuric acid and heated it at 170 degrees centigrade, almost at 170 degrees centigrade, then through dehydration alkene form, right? So ethanol, you can prepare ethene from ethanol when heated in the presence of concentrated sulfuric acid, ethene form through dehydration. The third method is we can synthesize alkene from alkyl halide. Again, there are two methods. We are using vicinal dihalides. I have already told you vicinal means same side, that two halogens on adjacent carbon. One halogen, this is a halogen on this carbon, and the same halogen with in another carbon. These are called the vicinal halides, vicinal dibromo, right? And अगर इस कार्बन के ऊपर ही एक हेलोजन हो तो इसको हम जेमिनल कहते हैं, ठीक है? When alkyl halide treated with zinc in the presence of ethanol, then it is heated. In the presence of ethanol, it converts into ethene. Zinc bromide, we are getting zinc bromide as byproduct. The main product is alkene, but this zinc bromide is as a byproduct. How we will basically preparation of alkene from vicinal dihalides, we can process this reaction if there is vicinal dihalides, right? Basically these are the 1,2-dibromo ethane when treated with zinc dust in the presence of methanol as a solvent, and when it is heated, initially this zinc attached with this bromine, right? Then it will convert into ethene and zinc bromide obtained as a byproduct. The main product is ethene. So vicinal dihalides are the source to preparation of alkene, right? The second process, how is alkyl halide, we can prepare alkene from alkyl halides when alkene is treated with alcoholic potassium hydroxide, then through elimination reaction, alkene obtained. We get alkenes, right? But this is a special case. Here you see the carbon and the carbon directly bonded with a functional group is called alpha carbon, and the carbons adjacent to alpha carbon is called beta carbons, right? Now, what actually happened, this elimination, how this elimination takes place? Suppose we can use potassium hydroxide here, alcoholic potassium hydroxide. Sometimes we are using sodium hydroxide. Suppose this is an alkyl halide, this is alpha carbon and this is beta carbon. Initially, the base abstract proton from beta carbon, right? From beta carbon, base abstract proton from beta carbon. As a result, carbonyl form in this stage, and this carbonyl attack on this bromine lead to the formation of this olefin. HBr की elimination हो जाती है यहाँ से और इसके जरिए olefin बनता है. तो basically base abstract beta hydrogen, right? So beta hydrogen की abstraction हो जाती है. इसी तरह से आप यहाँ पर हम देखते हैं यहाँ पर there are two beta hydrogen. So potassium hydroxide, which beta hydrogen is abstracted? Either this terminal beta hydrogen or this secondary beta hydrogen. Okay. If we just abstracted this terminal beta hydrogen, this lead to the formation of this olefin. Sorry, here double bond not mentioned. There is double bond, right? This is minor product. This is unstable product and minor product. But basically, this base abstract secondary hydrogen, secondary beta hydrogen. एब्स्ट्रैक्शन इसकी हो जाएगी तो इसके नतीजे में इसके ऊपर नेगेटिव चार्ज आ जाएगी और ये अटैक करेगा इस क्लोरीन इसके ऊपर और इस क्लोरीन की एलिमिनेशन हो जाएगी. एलिमिनेशन के नतीजे में हमें ये ओलेफिन हासिल होगी. ठीक है. अब ये जो ब्यूटुइन हासिल होगी ये हमारे पास मेजर प्रोडक्ट है. व्हाई इट इज मेजर प्रोडक्ट? बिकॉज दिस अल्कीन, द अल्कीन, व्हिच अल्कीन इज मोर स्टेबल? दिस terminal alkene is more stable or this alkene is more stable? Those alkene is more stable which is directly bonded with alkyl groups. जिनके साथ डायरेक्टली अल्काइल ग्रुप्स अटैच हों वो अल्कीन ज्यादा स्टेबल होती है. ठीक है. इसी वजह से ये स्टेबल अल्कीन जो बनती है ये वाला हाइड्रोजन यहाँ से प्रोटॉन एब्स्ट्रैक्ट करेगा तो इसके नतीजे में जो हमारे पास अल्कीन हासिल होगी ये स्टेबल प्रोडक्ट हासिल होगा लेकिन ये अनस्टेबल प्रोडक्ट हासिल होगा. बट एडवांस कोर्सेज में ये देखा जाता है ये जो टू साइंटिस्ट हैव डिस्कस दिस फेनोमेना. Setizers tell that proton should be abstracted from this hydrogen because it gives a more stable product. While Hoffman, another scientist, have discussed that proton, this base should abstract proton from this carbon. It gives unstable product, but this is not for this reaction. There are other reactions which have different conditions. We will discuss in other lectures, right? So basically, in this reaction, three important phenomena occurs. Initially, the base will deprotonate the haloalkanes, right? Base deprotonate, that abstraction of proton from beta carbon, right? In first step, as a result, there is carbonyl form. In second step, it just attack on this carbon. As a result, in second step, the leaving group, that is chlorine or halogen, any halogen, in second step, the leaving group will depart from the molecule in second step. And in third step, the deprotonated carbon will rehybridize from sp3 to sp2. Suppose you see here, in this starting material, the carbon which is directly bonded with halogen is sp3 hybridized. When elimination takes place, elimination in the presence of alcoholic potassium hydroxide, we get this product, this major product. But this carbon in this stage sp2 hybridized, because carbon carbon is bonded with double bond, that carbon is sp2 hybridized. And if there is a triple carbon, अगर इसमें ट्रिपल बॉन्ड हो तो वो sp hybridized होगा, ठीक है. So the deprotonated carbon, that is this one, right, this carbon will rehybridize from sp3 to sp2. So this is the process. Any question?
No, sir.
सर 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 ये प्रिपरेशन ऑफ अल्कीन्स में जो स्टेप है